Let's continue with the cells of the nervous system. We have seen the neurons. Now let's take a look at the glia cells. Astrocytes are star-shaped cells of the nervous system. They are the most numerous cells of the nervous system. So these cells must be very important. In fact, astrocytes serve to nourish neurons as well as to remove waste and toxins from the brain. So in this diagram here, you see the star-like astrocyte. One end of the astrocyte have food processes that wrap around blood capillaries. So nutrients will be drawn from the blood capillary towards the astrocyte and delivered to the neurons. Neurons will produce waste and toxins and sent back via the astrocyte to the blood. Astrocytes form what we call the blood-brain barrier, or BBB for short. Next, we have the microglia. These are the phagocytes of the CNS. Okay, so when we say these are the phagocytes, basically they phagocytose bacteria as well as dead nervous tissue and debris. Notice that microglia cells are also star-like in shape, but they are much smaller and less numerous. The third group of glia cells are discussed together because basically their functions are the same. Oligodendrocytes and Schwann cells form the myelin sheath that wraps around the axons of neurons, enabling rapid conduction of action potentials. So you can think of the axons as a copper wire, and the plastic housing that wraps around the copper wire will be the myelin sheath. Okay. So how do they differ, the oligodendrocyte and the Schwann cell? They look different and they are found in different locations as well. Okay. Oligodendrocyte. As the name implies, oligo means several, dendro means tree-like. So one oligodendrocyte will wrap around several axons. So in this diagram here, how many axons are wrapped by one oligodendrocyte? There are 3 of them. Okay, one oligodendrocyte wrapping around 3 axons. The Schwann cell, on the other hand, okay, only one Schwann cell wraps one axon. Okay, so you see here the axon and the myelin sheath produced by the Schwann cell, by one Schwann cell going round and round the axon like a Swiss roll. Okay, and the parts of the neuron where you don't have the myelin sheath, these are what we call the nodes of Ranvier. Let me illustrate what do I mean by myelin sheath allows the rapid conduction of action potentials. So I keep a blank slide. So if you recall, this is the axon, and maybe this is the cell body. Okay, so the axon belongs to the neuron, and the other end of the neuron you have the axon terminal. So when we draw the myelin sheath, it looks like this. And this myelin sheath are produced by the oligodendrocyte in the CNS or Schwann cell in the PNS. If I draw another one without the myelin sheath, it will look like this. Okay. So the axon serves like a copper wire. The myelin sheath serves like the plastic wrapping around the copper wire. Myelin sheath serves as an insulator and it allows rapid conduction of action potentials. So what do I mean by rapid conduction of action potential? So so you have the information flowing towards the dendrites picked up by the cell body and converted to the action potential at the axon hillock. Okay, so here is where you will detect the first action potential at the axon hillock. And in a myelinated neuron, the action potential would be jumping from node to node. Okay, pardon the spelling. This pencil is not very high resolution. Okay, so the action potential will be jumping from here node to node. In an unmyelinated neuron, basically the action potential will be traveling across like this. Okay, so it is much slower as opposed to the myelinated neuron where the action potential jumps from node to node. Okay, here is the gaps where there is no myelin sheath is what we call the nodes of Ranvier. Technically speaking, the myelin sheath is made up of lipid, so lipid does not transmit electricity very well. But because there are gaps in the myelin, in the axon, the nodes of Ranvier is the action potential jumps. So the transmission of action potentials is much faster compared to the unmyelinated neuron. The next Glia cell that we are looking at will be the ependymal cells. Ependymal cells are ciliated epithelial cells that line the central cavities of the brain and spinal cord. Ependymal cells produce the CSF or cerebrospinal fluid for short, which cushions the brain from shock and injury. Okay. So I have a question here. This will be in the mail quiz. Where is ependymal cell found? Is it in the CNS or PNS? Okay, this activity, you please record this activity and post on mail. Okay. So you take a container. It can also be a water bottle or a disposable plastic container. Make sure the container can fit an egg. Fill the container with water and place an egg in the container. Shake the egg container and upload the video to discussion board. Does the egg crack? Okay. What do you think mimics the CSF in this experiment? What do you think is the brain in this experiment? Okay, so record this activity and post on mail. It should take you less than 5 minutes. The last Glia cells that we are looking at will be the satellite cells. Satellite cells are only found in the PNS. Okay, so take note of where your Glia cells are, whether they are found in the PNS or CNS. It's quite important. Satellite cells serve as protective and cushioning cells, and in this diagram they are seen surrounding the cell body of neurons in the PNS. Okay, so this function to protect and cushion cells in the CNS. Function. Okay. Question here. What kind of neuron do you think this is based on structure? Is this a unipolar, bipolar, or multipolar neuron that you see in this diagram? Okay. Okay, 1 year ago, 2 doctors were sacked by the hospital for injecting bowel bacteria into the brain cancer patients. Okay, so they take the bacteria from the large intestine and inject it into the brain of these brain cancer patients. Their idea was that by injecting the bacteria, we can stimulate the immune system to get rid of the cancer cells. Okay, so anyway, my question is, which Glia cells are likely to be present in large numbers in these unfortunate patients? Okay. So you have introduced bacteria into the brain, and what Glia cells are likely to be present that can deal with the bacteria? Okay, so there are only one phagocytes among the Glia cells. This will be the microglia. Okay. They are the immune defense cells of the nervous system. So summary of lecture 4.2, you need to know the structure and function of a neuron very well. You also need to know the different ways to classify neurons. There are 2 ways basically, by function and by structure. By function is depending on the direction of transmission of information in or out of the CNS. So we have the sensory neuron, which transmit information towards the CNS. We have the motor neuron, which transmits information out of the CNS towards the effector organs, and the interneurons, which connect the sensory to the motor neurons. And the other way to classify neurons is by structure. Basically, you count the number of extensions that emerge from the cell body. If you have 1 extension, it's called a unipolar neuron. 2 extensions from the cell body, bipolar. Multiple extensions from the cell body, multipolar. Okay. Number of extensions from the cell body. And lastly, you must know the functions of the Glia cells very well, as well as where they are found, whether they are found in the CNS or PNS. Okay, so this is one of the mail quiz question. Can you identify the cells labeled 1 to 7 in the diagram here? Okay, and a second question is, do you think this diagram is representative of the CNS or PNS? That's the end of lecture 4.2. Okay.